And hello, and thank you very much for joining our live webinar today. We're very happy to welcome our channel partner members, including those loyal members of Seagate Insider, to today's event. And we hope you guys all find the content really valuable and that we exceed your expectations. The goal of today's session always is to provide some thought leadership and education on a topic that has started cropping up in the media more and more, it seems like, and that is edge or edge computing. More and more data demands real-time processing and action closer to where it's created or close to the edge of the network away from the core. It's the crux of what we here at Seagate call IT 4.0. And as you hear from our speaker today, you should be asking yourself if you're ready to accelerate towards the business of tomorrow. And thankfully, we have a special guest today with us who's going to help us understand the basics of this concept and walk us through defining the edge, why the edge is emerging, use cases for the edge, and of course, as always, we want to get to the end and do some Q&A from our audience today. Today's guest speaker is Rags Srinivasan, who is Seagate's Senior Director of Marketing for Growth Verticals. And before we get to the presentation, I just want to do a little bit of housekeeping here and let you know my name is Joshua Walty. I'm Seagate's Global Partner Lead, and I'll be your host for today's session. So a few reminders for those of you who may be new to WebEx. To preserve the sound quality, all participants are on mute. And if you have any issues with WebEx, you can certainly reach out via the chat box to send a message to me for assistance. We will be answering questions throughout the presentation, but we'll do a big roundup at the end. So please submit yours ongoing throughout the session, and the team here will use the chat box to get back to you. And so you'll see on the screen how you can reach out through that chat box. And some of you may even find your way to the Q&A as well. We don't care how you find us, just get your questions to us. And for those of you who, like I said, may be new to WebEx, this is a slightly new interface. So you'll see on your screen how to reach out to us. Finally, all attendees of today's session will receive a follow-up communication with directions for how to access the video recording. And that's enough setup from me. Rags, I want to make sure to give you the floor. So let me go ahead and pass the ball to you. And let's get on with the show. You've got a lot to cover, as I know.
Yes, thank you, Joshua. Thank you for a very good introduction. Welcome, everybody. Yes, indeed, the edge computing has been in the news quite a lot there. So I want to treat this as a first opportunity for us to share with you all those great things that's happening. I want to think of it this way: at the end of this, you become more conversant with the terminologies and be able to speak to it, speak with your peers and your customers, and then be ready as those opportunities arise in the future. That's going to be a goal, a long-term learning goal for this. So without further ado, let's get started on this. So if you were to just go into your Google search box now and type in edge computing, you'll be amazed to see in just a few short years, you're getting about 175 million search results. In fact, I subscribe to many of those news alerts and other things, and every day something new is happening, including about how edge is better than cloud, those kind of controversial headlines there as well. There's so much in the news in here, and people are just coming out of this whole cloud thing when we all thought we just understood cloud and we built it out, and now this. So what is it? So let's get right into it. This will be a short presentation, although we use a lot more of the visual aid, but I want to break this into three parts. One is, let's define the edge. They ask those fundamental question of what is it? And why is the edge emerging? Like, why do we need this now? Didn't we just get done with everything with the cloud? And finally, what are the use cases for the edge, which opens up all the opportunities that you seek as your customers seek, and be able to talk to them on it. And I also have a brief interlude in the middle, which talks about something new and exciting that you're seeing in the news as well, which is 5G, which we will take a brief detour to cover that as part of the edge and why it's relevant to it. So what is the edge? I'm going to take an easier route first to say, well, what the edge is not. With this kind of emerging technologies, it's easier to answer this before we get to that final definition. So let me start with saying the edge is not the big centralized hyperscale cloud. The things that you and I are used to with all our apps, files, and everything and emails reside on. It's definitely not the edge. It is not a climate-controlled, multiple buildings falling across a large area. That is not the edge. Well, the edge is also not a specific device or a system or a server. People have asked me, like, is this box an edge there? But it is defined more by the location. So it's the movement of your data storage, your data processing, and any kind of compute resources like your servers. It's the movement of those away from your centralized location to the borders of the network. And why is this happening is, well, because these resources, storage and compute, need to be closer to where the data is getting produced and produced in much higher volume these days. So this is happening around you. Like you ask, like some of the icons, you look at this, you have your Fitbit on you. You have your drones probably you're getting for holidays, and your mobile phones and smartwatches and your homes and industries and everything. These are all far outside and creating so much of data. It requires the edges, the movement of the data processing to be closer to these data sources so the data can be captured and processed there. So we define the edge as this way. It's defined by the location, not by a specific device or a server. The edge is the movement of data storage, computation, and processing away from a centralized location to the borders of the network to be closer to the data sources. This could be on a cell phone tower, this could be on a building as you drive by, or it could be, say, even on a barn on a farm as well, as you're going to see later on. That's the edge. So why is the edge emerging? This is a fundamental question. Like, why are we even doing this? To go talk about so much of cycles to define it as well as build out these things there. Many other analysts and other experts have put forward several different reasons for why the edge is emerging. From a Seagate point of view, we looked at all the different aspects, and we talked to our own people within our factories. And we talked to several other people in this specific areas, and we distilled these reasons for the edge to 4 main things. And I'm going to cover each one of them later on as well, but let me list out those first. It's number 1 is about the low latencies in terms of how fast you can get a response. The second one is the data volume. You saw the number of devices. The devices are increasing and the amount of data they're creating is increasing. And the cost not only to send the data, but also to store all those data from billions and trillions of devices at a centralized location. And finally, the most overlooked item, but is very important, is compliance that prevents some of the data from moving out of a geographic location. Well, let's double click on each one of those. Latency. The textbook definition, if you will, is more of how long it takes for a certain data bit to go from one location to the other. In many of the applications, say you think of an autonomous car or a factory or drones, there is a need to collect the data and act on it within a specific period of time. You really don't have so much of a window to collect the data, send it over the internet to a centralized cloud, which could be located thousands of miles away, have that process, and then sent over back to, say, tell the car, now stop, don't hit the pedestrian. So it's really not an acceptable solution there. There's a very short window of time measured in milliseconds where the decisions need to be made. And the second option is the amount of data volume. As the number of devices increase. They are in the order of hundreds of billions, could hit trillion very soon. And also, they're getting very prolific. Think of your drones and drone-mounted cameras, as well as a car with multiple LiDARs. They're all collecting a considerable amount of data. There's simply not enough pipe to send all this data out. So what you end up being is really today, if you look at the latest statistics that came out like from AT&T, in a month they carry about 225,000 petabytes of data. With those networks so much overloaded, you can't have a way or send all the data from the endpoint to a centralized location. You get into this bottleneck. And even if you were to somewhere find a way to send it, the cost of sending all this data is prohibitive because you're competing with multiple different resources there. And once the data gets there to a centralized location, the complexity of such a one cloud to handle trillions of devices is simply not an affordable option there. And finally, the compliance option there. There are very specific rules, and some of them emerging, if you look at it, on who owns the data, and how do we make sure that data does not leave a specific location. Some of those are industry-driven, and some of those are regulations from the government. Those things prevent some or all of the data from moving away from a location where it is created to a centralized location there. So due to these four reasons, the latency, the amount of data created, the cost, and compliance, we see edge is becoming an option of moving data processing, storage, and compute away from a centralized cloud to be closer to the data sources. You'll hear me repeating this part a few times. I really believe in saying this over because there's so much confusion around what is edge. It behooves us to understand all aspects of it as we proceed along this. So what will the edge look like, or how will the edge manifest? Well, there are multiple different ways you could say, depending on the different use cases. But one thing that's common in every way the edge rises is those four reasons that we laid out. That defines the edge, and that actually brings about the installation of edge in many of these use cases. The edge indeed is unlike the cloud where you have one specified location and within that many different applications live in. The edge is made up of many different use cases, and I'll show you those variety of them as we move on to the third section. There are many commonalities defined by those four factors, but there are also some key differences. The differences are in the kinds of endpoints, some of them very prolific, or some of them just a few data points that they collect, like your temperature monitor or a humidity monitor. Compare that to an autonomous car mounted with cameras, LiDARs, and radars that could be generating about 4 terabytes of data. That's per hour of driving there as well. And the next difference is in how does this data get from those endpoints to these edge locations. And finally, how the data ends up from the edge to the centralized cloud, which is the final resting place there. A point that I want to call out here is the edge does not replace the cloud. It is not edge or cloud. It's edge with cloud helping solve these newer data problems that is arising there. Well, we alluded to this question in the beginning. Where is this edge going to be? Where does the edge live? For this, I want to start with, this is where the biggest driver of edge you're going to see, start with more of the telco infrastructure. And I want to start here because every one of you here have at least one mobile phone, and you have things that are connected to the networks, and you can relate to this very well. In our analysis and from talking to many customers and partners, we see that telco is going to be the first major and largest implementation of the edge. Because these telco networks, they already have infrastructures that are distributed out there in the network. As you drive by your highway, you would have seen those big cell phone towers every few miles or so. Or when you're seeing your local city streets, those simpler central offices are the switch boxes there. In all these locations, create a great opportunity for the telco networks to use their current point of presence to build out the edge. That's one of the reasons why telco is going to take the lead in here. Together, the telco networks are also in the process of building out their private cloud, specifically for their customers' content and other purposes. Together with their current distributed infrastructure everywhere, with their private cloud, and add to the existing public cloud as well, they will become the very large edge infrastructure provider. And that is only one aspect of it because they're already there at the edge, hence they can add to it compute. But there's another technology driver that's happening that makes edge even more relevant to telco. That's the emergence of 5G networks. So if you all take out your phone and see, you probably see the 4G LTE on your phone. The next big change that's going to happen in the wireless technology is the next generation of the wireless, the 5G. And there are news reports out there that as early as next year, we could be seeing some of the 5G handsets coming in there. So let's take that detour I told you about, the relevance of 5G, and you'll see why it becomes an edge driver. Well, to set up again the 5G, let's see the differences between a 4G versus the 5G. Let's take the frequencies. Today, the frequencies in 4G are overloaded. We all have, as I said, at least one mobile phone, and predominantly the devices on the 4G network today are phones. And some of them are the connected cars, actually. There was a research report came out yesterday that from AT&T that stated they currently have 27 million cars on their network there. But it is still, compared to the billion numbers out there, it is a very small number. It's limited in how much can be done. That's a huge difference with the 5G, where the frequencies are far less cluttered. So what that means is in a 4G, there is a limit to the number of devices that can be supported in a smaller geographical area. On the other hand, with 5G, you can have millions of devices in a square mile area. That means it's not just any more phones, it's those multiple different sensors, drones, cameras, cars, you name it. And in fact, it is likely those things are going to outnumber any of the user-driven devices that we are seeing today with 5G. With 4G, the data can travel over long distances. That's one reason why you see those cell phone towers that are miles or so apart there. But you are still, when you send data from your phone, you would have seen it when you're trying to upload a video you shot into your cloud provider. The data, it takes a longer time. The data travels slower, especially in the upstream direction. 5G, the data travels faster and in both directions at the same speed there. It travels, although one of the bigger changes, the 5G uses millimeter waves, which limits the distance it can travel. So it can only travel over a few city blocks, versus a 4G radio wave can travel up to a mile or so. So in 5G, you have data travels faster, but over targeted shorter distances. So net, there are going to be far more devices supported, and all those creating so much of data, and there's a need for all that data, makes 5G a clear market maker in driving the edge. you're going to see with 5G the kind of sea change we saw with the original internet or the iPhone revolution that came about. Like, who would have thought a phone could disrupt the taxi cab industry, right? So we're going to see with 5G newer use cases, newer markets, completely new product innovations, and as well as everything that we know about current verticals could get disrupted. So it is going to be a clear market maker. Let's bring it back into 4G versus 5G. What you have, so you have predominantly user-held devices that is connected through the cell phone network, the data going to the cloud. But with 5G, you have far more than just phones. You have cars, smart devices, drones, and everything. As you see them crowd out just the user-held devices. And they will talk to an edge location because it's so much of data coming from so many devices. You simply cannot, that volume reason that we saw, the second reason for the edge, you can't send them to the cloud. You need to process them closer. These data will get sent to those edge locations, eventually being sent over to the cloud. So that's where we bring together with 4G versus 5G, when 4G enabled more of consumer and business communications. In the case of 5G, the communications are going to be machines talking to other machines, not just in a few millions or billions. It's going to be in the order of trillions, sending, exchanging information, and building a self-sustaining network. So this is why we believe with the current distributed infrastructure and the technology drivers, the telco edge will arise as the 5G comes online. So the key things that you note in a telco and a 5G infrastructure, of course, those base stations, the cell phone towers, then near them, what we call the micro modular data centers. The compact form of storage, compute, and other functions that are needed could be in the size of your trailer, the 18-wheeler, or even smaller, like the storage pods that you see will be a micro-modular data center being distributed out in the field, is where the edge will get built out. So as the 5G help drive more bandwidth to send more data, and as it unlocks new use cases, and finally, people find value for this data, you will see the emergence of the edge, especially when all these data cannot be sent over to the cloud. It demands now processing closer to the data source, where it makes perfect sense to put those edge processing, edge computing closer to these cars as they drive by to get the data processed, make the decision quicker, and leverage the cloud for more of a longer-term storage and or the next level of higher order analytics that you would want to do with that data. Okay, that completes more of the second part. Now we are under the final thing where you want to ask, well, what are the specific use cases for the edge? Well, before I get into that one, let me bring back some of the elements that we've been talking about in this architecture. First, we saw the endpoint, what we call the endpoint, which includes not just anymore the phones, includes anything that is connected and creating a lot of data from your camera, sensors, cars, everything. Then the edge, which could be on a telco tower or a micro-modular data center, could be on a factory floor or on a barn. And finally, we call the core, which could be the private cloud or a public cloud. In addition, we need to talk about how does the data move from one to the other, from endpoint to the edge and edge to the core. The transport, the Wi-Fi and 5G, of course, and then the connected IP, WAN, LAN, but also there is this, in our view, we introduce a fundamentally newer way to transport data, which is the data shuttles in here. With this architecture in here, we look at some of the three main use cases that we see where the edge is relevant. If we looked at the whole market as a whole, and we found out there are about 110 different use cases. Almost all of them will be relevant in a few years as well. The reason where we picked out these three is the demand is now, the demand is higher, and there's a lot more innovations happening with the ecosystem. That's the reason why you see those three, what we are going to call out. Now, number one of those is the autonomous vehicles. This will, if you look at add to that the telco network and how the cars drive around, this probably will be the biggest edge use case combined with the telco. You have anywhere from today your connected cars where you get your maps and music delivered to you, all the way up to what are known as the level 5 autonomous vehicles, which in a way, as you see it, you don't need to be looking at the road and driving the car. It takes care of everything. It is a few years away to the get level, but what is enabling all this is if you have seen any of these cars drive by in your streets, if you are in Pittsburgh or in the Bay Area, you would have seen these pictures or seen these cars right next to you. There are multiple different LiDARs and radars mounted on them, as well as cameras capturing this data. These are significant data collectors. In addition, as the smart city emerges, as these cars drive by in those smart cities, the car itself becomes a data source. The car sends signals to those traffic lights or to the other cars in there. I recognize that smart city could itself become another major use case, but for the scope of this talk, let's stick with the car as a data source here. So how does this edge use case work with the autonomous cars? Well, the first thing to know is we are still in this test and development phase, and we probably will be in this for at least a year or two, if not a little bit longer in this space. That's where you see all those many cars drive by right next to you with two test drivers collecting data. During these test runs, like the cars collect significant amount of data. It's far more than the car in the real production time would do. So this gets stored inside in a data module inside the cars, and then when the car returns back to the lab or wherever the data get processed, the data module is moved from the car and then put it inside a micromodular data center where they then let loose the different data processing that is needed, the artificial intelligence and machine learning that gives insight into how to bring this about to a production. Because of the amount of data that is collected in each test run, the data shuttle and physically moving it is actually the preferred way to transfer data rather than connecting it to a USB 3 or a Fire Thunderbolt or anything else to trying to wait to send that data out. Because by this kind of modular data shuttle approach, you can simply take out the data shuttle and put it in a rack and get processing going while you put in another shuttle inside the car, and the car can go back into the streets there without waiting for hours because you have terabytes of data to transfer. And then the second phase, I hope this happens within 3-4 years as well, because I have a 14-year-old whom I don't want to drive in the streets. We want autonomous cars by then, is when you and I will probably have access to these autonomous cars on the streets. In these cases, they may not be collecting as much data as during the test phase, but still with those 7 different cameras, at least 7 different LiDARs, they still are generating a lot of data, wanting to make decisions quickly. So in these cases, for the real-time decisions, the data needs to be sent over quickly to the edge. That will be over 5G to get processed and the decisions made there. But once the data reaches the tower, imagine all those many different cars sending over data. And to send some or all of the data back to the cloud, it is not possible to put them on the IP WAN and send it over. This is where you take advantage of the data shuttles, where you store data in transportable data modules and then put them on a reliable transport layer and send it out over to the cloud where it gets ingested, and where data from multiple different edge locations get consolidated for the next level of processing. What that leads to is, like, you have a set of cars learning and driving in a particular geographic area. They send that knowledge over to a centralized cloud where it collects data from multiple different locations, where they form a much better picture. In that way, one car need not drive in every other street to know how to do that there. It gets that collective knowledge from the other cars driving in that area. And to enable that kind of collective centralized learning, the data needs to be sent over from the edge to the core. And considering the volume of data, the best option here is physically transporting, putting it on a data shuttle and then sending it over instead of trying to send it over an IP WAN. Right. I think the second major use case is how we are going to feed the next billion population for this world. The industry, if you think about farming, like I was in Walgreens the other day and looking at the bookshelf, and I still was surprised to see the Farmer's Almanac standing out there in the bookshelf. So this is an industry that relied so much on Almanac to predict things. Now things are changing beyond our imaginations there. It is easier for you to imagine those sensors inserted into the soil in other places. You may even have a rain sensor in your lawn to know when to water and not to water. There's multiple different such sensors in the farms. But the bigger change in data creation is going to come from the use of camera-mounted drones in agriculture. Because these have the capability to capture these images to find out so many new things, like monitoring crops and see if there is enough coverage of water and fertilization, finding if there's any infestation before they arise and spread across multiple areas, and to look for anomalies across the field, and better utilization of resources, especially in this day and age when you have so much of scarcity of water. And finally, to know the total yield. That's important for the farmers, for the financial modeling, and for the future growth. So how does the data flow work in this scenario? So you have many agricultural drones flying around this field and collecting several aspects of the data. It could be just looking for whether the particular area is watered or not. The other part could be just monitoring the soil. These drones then send the data over either the Wi-Fi or more likely a 5G to a nearby location. In a very large area in a single contained form, this location could be the barn. The barn could become the, so to speak, the edge micromodular data center. In case of not so real-time cases, where it is okay for you to hold on to the data for a few minutes, when the drones return to the barn for a recharge, the data gets transferred. And then either some of the processing happens there, or it is put on a data shuttle that we saw about, and then sent over to the core, which could be a private cloud, could be a specific agriculture cloud built by some of the big makers, or it could be the public cloud as well. In any case, when you want to transfer large amounts of data in the order of hundreds of terabytes or so, especially video-driven data, you're going to find sending them over the current IP network is not going to be a possibility. Using the data shuttle is going to increasingly become the cost-efficient, effective, fast option to get the data out. Finally, let's bring up to the last use case, which is smart manufacturing. Using robots and artificial intelligence is not new in factories. That's the one that started the industrial revolution, the IT and the industry 3.0, if you will. What is happening now is things are getting even more complex. what we produce now, what we use, think of, just look at your smartphone or your smartwatch in there. Things get ever more sophisticated, a lot more things packed. And we call in here, in this day and age of manufacturing, even nanometer matters there. So while the common scenario in a factory is you have many different sensors. Yes, you can look at the sensor data and predict if a particular machinery is going to fail or not. That is one by itself a great value for the factories in there. But there's only so much data that gets generated by looking at those logs and other things. What's emerging is the high volume scenario. It's one of the newspapers recently wrote an article. They called it the factory robot gets eyes, which what they mean is the use of cameras within the factories that drive the many different things now you can do, which was not possible before. Especially using those cameras and the images to do real-time quality control, efficiency, and almost change every part of the manufacturing process. In many different smart factories, and you'll see that everywhere where this precision matters, nanometer precision matters, production quality matters, volume matters, you'll see the use of HD cameras or electron microscopes has become the chosen method of instrumentation to find everything from improving your overall manufacturing assembly line to even say the predicting in terms of the next product change that could be needed there as well. That's the power of using images with many of the advantages in AI will result in a very effective smart factory that no more relies on hundreds of hours of trying to find out a simple problem, rather increasing and accelerating how things could produce to meet this changing demands of the world. So what is the data flow architecture look like in a smart factory? In some ways it is similar. Now your sensors, as we talked about, the endpoints are different. These are the HD cameras or the electron microscopes that are constantly manufacturing, constantly taking pictures as the parts go by. And for real-time decisions, where you want to make a quick decision on whether a particular widget is an anomaly and needs to be tossed, or a particular machinery is in the brink of falling down. So you want to make quick decisions. The data that is captured is sent over local network and sent over to an on-site edge. So the edge in this case will be the factory floor itself. In cases where you don't have that level of immediacy, but you just still have a lot more of the data, in those near real-time processing, the data can be sent over 5G or to a micro-modular data center, which could be like a consolidation point for multiple different factory campuses, where the data gets sent over for the next level of analytics there. And from then on, for the longer-term storage and processing, you guessed it, it's the data shuttles that comes into play, where you transfer over the data into data shuttle and send them over to a much faster, efficient, scalable way to send large amounts of data. So quickly, we'll bring this back to conclusion about the edge. So we saw about what is the edge. It is not the centralized cloud. It's the one emerging architecture that bridges the gap between where the data is getting created and the centralized core. The edge is being driven by 4 fundamental needs: the latency, the high data volume, the cost and compliance, and 5G with telco is going to make edge even more relevant and the adoption faster. And we saw there are 110 use cases for the edge at least, and we dove into 3 of the key use cases: the autonomous vehicles, agricultural drones, and smart manufacturing. Thank you very much for your time. Now I'll open up for questions.
Thanks, Rags. This is Joshua here. Great presentation. We've had some questions come in that I've sent your way. So let's switch slides just a minute while you have a chance to review those. And lots of engagement online. It's really great. We know that this has been a topic that we get from all sorts of different areas, whether we're doing field marketing efforts or other webinars. So great topic to cover. I want to jump in really quick as you're reviewing those questions, Rags, and just do a quick plug for the Seagate Insider for Partners. This is Seagate's partner program. And as a channel reseller, integrator, consultant, or even business owner, membership in the free program gives you access to the latest tools, sales aids, training, and support materials from Seagate. If you're not a member and receive today's invitation from a colleague, we encourage you to take a few minutes to sign up after this webinar. Lots of benefits in there. Benefits vary by region, so take a look. We'll be sharing the URL for that very shortly here, which you can see on the screen. Rags, we had a question that came in. Maybe you can kick us off. You used the term data shuttle a few different times, and we had somebody that just wanted kind of a brass tacks. Can you define that a bit, kind of what you mean by that?
Yeah, so think of it this way, that you have things to move from your home when you move from one location to the other. You have a safer, secure way that you want to put inside and send it out. Now, what is more important asset to a business than its data? And when you have large volumes of it and you want a simple, secure, efficient way to send that from your factory floor into, say, your industrial cloud, and the option is not putting it over the current IP network to send it over. You need a different way. That's a data shuttle. It's a modular, simple, secure, efficient transport mechanism where you just load the data into it in your location. The data stays secure and trackable, and that gets sent over. Could be a public courier network, or it could be a dedicated courier network, and data manually, hundreds of terabytes of data travels on a truck and reaches the final location and gets ingested into the public cloud. So that's a data shuttle.
Got it. Yeah, I think we're going to be hearing more about that term as the amount of data that people are looking to action on just grows and grows. We did have another question that came in, Rag. Someone was interested to know how storage and computation are integrated to form what they're calling micro-modular data centers. And what's the role of storage versus computing? And how do they interact? Big question.
Yeah. Yeah, it's a very, very, very thoughtful question there. First, it starts with data. It's a data-centric world. There's all the data that is getting captured at or near, say, a factory floor or a barn. You need a efficient, faster storage to first get the data in place. And then you are putting the data to work, taking advantage of the many advances that you're seeing, the artificial intelligence and machine learning algorithms there. That's the processing which needs computing functions. So if you put this, as well as any other networking, other functions that is needed, if you put this in a compact way, it's the equivalent of, say, shrinking your big hyperscale cloud-like functions in a smaller form factor, which becomes the micro modular data center, which could be housed on a trailer and put on your parking lot. So it gets processed right there instead of you having to send those petabytes of data over to a cloud and having to get it processed.
Very cool. You know, we also had, during the presentation, we had some folks share with us kind of the verticals and industries and the focus that you know, they're interested in. And I guess it kind of begs the question, you know, why you think certain industries are adopting edge technology faster than others?
Well, that's, and I think to know there's many of them who are coming into this. It's needs driven. They now realize with the help of data, they can fundamentally change how they are doing business. And it gives them the competitive edge as well as leaving behind the competition if they were to effectively use the data in here. And they are instrumenting and creating so many new data sources. And they're simple, and they look around, how do I get it done? there's simply no other alternative today available for them to make sense of the data and get value from the data. So they are taking things into their own hands and building out these edge infrastructures right where they are. Now, it includes factories and cars, and where they don't have another option, so they are building it and driving it to adoption faster than other places.
Got it. And I know just overall, we've had, industries have been using remotely sensed imagery and data for years, right? I mean, there's probably folks on the line that have been involved in that, and they've been doing it to enhance their actionable knowledge. How is the edge different?
Yeah, so capturing images is not new. In those cases, the cases that you mentioned about remote sensing, we're not acting on them for immediacy. That's not real-time processing. So think of, say, a plane mounted with many cameras flying over a large region. It can go around, collect the data, and come back, and eventually they can get processed. That's more of a batch processing. The edge, you saw the 4 drivers. The number one is latency. Then if a car is driving by on a street and it has to make a decision whether this person in a chicken suit is a chicken or a person, and to quickly make the decision to stop, it needs that edge to be closer. The edge is about helping that latency and enabling real-time processing. And the second aspect also is the amount of data that is getting created with the advances in the sensors and the HD cameras. You are now seeing far more, orders of magnitude higher amount of data that is getting created than what you saw with just the remote sensing. And the third aspect is the advances in computing. Now we have at our disposal immense computing power with the GPUs and software processing like the artificial intelligence and machine learning, which can be brought closer to the data source. And that's another big difference that was not available just in the previous remote sensing use cases.
Got it. I did check the Q&A box, Rags. We did have somebody back on the shuttle topic. Someone was wondering, who are building those shuttle devices today and who's buying them?
So it's a very good question. So one thing for sure is if you're interested, we will be happy to set up a separate one-on-one conversation with you. But we think of this more of an emerging space where there is a need that is identified to move significant sources of data, significant amount of data from one source to another there. So think of that as an emerging market. There is a market opportunity. And we, as you said in there, we want to come back to this group and showcase the opportunities and aspects and deep dive into that very specific questions.
Got it. There's kind of a follow-up to that. We've had some questions come in, and just kind of curious if you've been traveling around, you've been trying to educate people from the Seagate perspective, and I'm just curious if there's typically one contact within a company who champions the move to modernization, or do you find it's the whole leadership team getting on board, somewhat simultaneously, I guess?
Yeah, it's a mix of all these things. Number one source I find is the people with lines of business. It's not the traditional IT or the procurement folks who are driving this. It's the people who run the factory or who have to make a decision. They are asked to reduce the quality control issues, increase throughput and productivity. They are the one taking things into their hands and being the change agents and bringing about this transformation, digital transformation within the industry. The IT team is now getting a lot more involved, and they don't want multiple different disaggregated solutions. They want to put forth best practices. They are becoming a trusted partner into this. And all those people who are also rolling this one out, they are coming in with a specific business challenge in their hand. They're not waking up and say, I'm going to build out an edge network or an edge system today. They come into work thinking, how am I going to reduce my quality control issues by 10%? How am I going to find faults in my manufacturing 6 months before it shows up in any customer field. So they're starting with the business problem and they are driving this change.
Yeah, absolutely. And I guess that kind of begs the question: if you could give only one piece of advice to make that technical shift smooth for those folks, what would it be?
It's about start with that purpose. Like, why do you want to make this? Not to be the coolest kid, but more of start with that business problem and start with a narrowly scoped one use case to begin with. Don't make it too ambitious. You could get there, but for the first phase, do a proof of concept or a pilot that is scoped to one specific problem, and work with the technology leaders who are willing to put the time and work in building the full solution with you.
Great. Good coaching. I did want to take a moment, kind of address what's on the screen now. We did talk throughout the session about IT 4.0, but there's plenty more to research on that. And on Seagate.com, we do have a resource page that you can see where you can start your journey finding out a little bit more about that. Also have put up the link to Seagate Insider for those folks who want to join that group and become part of a great enablement body of folks that are addressing these kinds of concerns. Also, we'll have the Live Data Labs link. Rags, I don't know if you want to kind of explain a little bit about this. This is a brand new kind of an innovative end-to-end solutions lab. So didn't know if you wanted to give them a plug here.
Yeah, definitely. I encourage everyone to go check this one out. This is a way for us to build an ecosystem. This is our recognition that in this emerging space, innovations happen at every point, and we want to do it jointly with our partners, customers, and the technology partners. So this is our portal to bring together that ecosystem and work with you to create something better for our customers. So do check that one out, and if you are interested in collaboration, let's get that one going.
Great. Well, I do want to thank everybody here for attending. This has been a great session, and we hope to have more sessions like this to offer some thought leadership to our channel members. I want to thank Rags. Definitely, I want to thank you for your time and your expertise coming on our stage today. And finally, giving you the last word. If you've got any final thoughts for these folks that kind of come from cross industries, have given us some great questions. What final thoughts do you want to send them off with?
I want to thank them first for giving us that full hour and spending the time with us. This is an emerging topic, and our goal really is to give you as much information as you need to engage your customers as you approach them, because they are thinking about edge, and you want to be ahead of in many ways, and to bring along your customers as well as intersect them at the right points. So there are opportunities there for all of us in delivering the needs. And thank you.
Terrific. Well, from all of us here at Seagate, thanks everybody, and we'll look for follow-up communications and some wonderful opportunities for future sessions. Thanks everybody. Bye-bye.